So far we've talked about the Pythagorean theorem and how to solve right triangles. Now there are two special right triangles that we can always figure out the sides of if we know any of the missing sides. The first of which is called the 45-45-90 triangle. And so in a 45-45-90, you could say, okay, well from 45 degrees, there's some leg, and from the other 45, there's the exact same length of a leg. And so we put it into our Pythagorean theorem, and we say L squared plus L squared is equal to the hypotenuse squared. Well, since L squared plus L squared is 2L squared, what we end up getting is 2L squared is equal to H squared. So we square root both sides, and we find the length times the square root of 2 is equal to the hypotenuse. So that's true for any 45-45-90 triangle. It says this, and this is the form we have. Leg 1 and leg 2 are both the same length, and the hypotenuse is that length times the square root of 2. So we can use that information to figure out some missing sides of a 45-45-90 triangle. Well, since this one right here is 45 degrees, this is 90 degrees, the missing side is going to have to also be 45 degrees. So that means since this side is 6, this leg is also going to have to be 6. And so x is going to be this amount, the length of the leg, times the square root of 2. And there's my answer. In letter B, okay, so we see that both of these sides are the exact same, both of the legs, which means both the angles are the same as well. And since it's a 90-degree angle for the right angle across from the hypotenuse, those are going to have to be 45. And so since we know that, x is going to have to be equal to 9 square roots of 2, the length of the leg, times the square root of 2. Now, you might have forgotten this, but the square root of 2 times the square root of 2 is going to just be 2. And so we get 9 times 2, which would be 18. If you wanted to check your answer with a calculator, you could. Here's a couple guided practice problems. Feel free to start trying those now. So, what if we know the hypotenuse, but not the length of the leg? Well, since we know that both legs are the same, it means that both angles across from them are going to be the same. So it's going to have to be 45 degrees each. So if we know that 12 is equal to the length of our leg times the square root of 2, how would we figure out what L is? Well, we have to undo the multiplying by square root of 2. So we divide both sides by square root of 2. And we get L is equal to 12 square roots of 2. Now something interesting about square roots is we don't like them on the bottom. So how do we take care of getting rid of those? Well, what we do is we multiply the top and bottom by the square root of 2. Like I just said before, when you take the square root of 2 times the square root of 2, it's simply just 2. And then we get 12 square roots of 2 on top. Now we can simplify because we see that we have a 12 and a 2. What number goes into both of those? Well, 2 does. So this becomes 6 over 1. So the length of my leg is going to be equal to 6 square roots of 2. And again, you could try that on your own. You could take 6 square roots of 2 and multiply it by the square root of 2, and you would get 12 for the hypotenuse. Here's a couple guided practice problems that you can try as well. Now the other special right triangle is called the 30-60-90 triangle. And the way we prove it is we start with a 60-60-60 triangle, which would be an equilateral triangle, where all three sides are the same. Let's say they're all 2x. Well, we can cut that right down the center, which would be an altitude. And so we end up getting this is 30 degrees, this is 60 degrees, and then obviously this side is 90 degrees. And so since we know that this is 2x, we know this is x, we can use that to find what a is, one of the missing legs. And so we put it into our Pythagorean theorem. We say a squared plus x squared is equal to 2x squared. So 2x, that quantity squared, is 4x squared. We subtract x squared from both sides. And so if you have 4x squareds and you take 1 away, you now have 3x squareds. So that a, that altitude, is equal to 3x squared. I square root both sides, and we find that the altitude is x times the square root of 3. So we end up getting this triangle right here. In a 30-60-90 triangle, the 30 degrees is the length of one side, The hypotenuse is twice as long as that side, and the missing leg B is the side times the square root of 3. So we can use this information to find our missing sides. Now, in example 3, 15 is that side B that's across from the 60 degrees. So that means that 15 is equal to x times the square root of 3. And just like we did in the last example, example 2, we divide both sides by the square root to find just what x is. And so we say x is equal to 15 square roots of 3. Now we don't like square roots in the bottom, so just like we did before, we're going to multiply the top and bottom by that square rooted amount. And so we end up getting 15 square roots of 3 over 3. And we can reduce that because both 15 and 3 have a 3 that goes into it. So it'll be 5 over 1. So the length of x is equal to 5 square roots of 3. Y, of course, the hypotenuse, is twice as long as that. So y is going to be equal to 2 times 5 square roots of 3. And we just take the 2 and multiply it by the number out front, 5, and we find y is equal to 10 square roots of 3. So x is 5 square roots of 3, y is twice as big as that, which is 10 square roots of 3. Here are a couple problems you could try as well. So example 4 says a company makes crayons that do not roll off tables by shaping them as triangular prisms with an equilateral base. 16 of these crayons fit in a box shaped like a triangular prism that is 1 1/2 inches wide. The crayons stand on end in the box, and the base of the box is equilateral. What is the dimensions of each crayon? So essentially what they're saying is, okay, so we have a crayon box that's 1 1/2 inches, but we need 16 of them to fit. And so it ends up creating a look like this if I was to open up my crayon box. So what we can do then is we can say, okay, well the bottom of each one of these 4 triangles has to add up to 1 1/2 inches. So we divide 1 1/2 inches by 4, and we find that each crayon is 3/8 inches along the side. Now since it's an equilateral triangle, it means that all 3 angles are 60 degrees, and we can create an altitude right here that cuts it so that we have a 30-degree angle here. So how tall are those going to be? So the way we find that is we say, okay, well, if each one of these sides right here is half of 3/8, it makes this being 3/16. So now to find the altitude, we said in a 30, 60, 90 triangle that altitude is going to be equal to 3/16 times the square root of 3. So I'll put square root of 3 with the 3 on top. And since we know that, we can figure out that each one is going to be 3 square roots of 3 over 16. So if I wanted to reduce that as a decimal, 3 square roots of 3 over 16 is approximately 0.3 inches. And we found the base to be 3/8 inches, which is approximately 0.4 inches. So what is the dimension of each crayon? It's about 0.3 inches by 0.4 inches.